I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this YouTube channel, I'm providing a detailed how-to guide on using TikZ and PGF plots. These videos are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Today we'll talk about the TikZ math library and its functionalities. You can use math functions both inside and outside of TikZ pictures. Math functions are useful in many scenarios in TikZ, especially in loops, which we're going to cover on the next video. I'll give a quick overview of how to call math functions, as well as some problems you need to be aware of, such as inaccuracies in the computations. This video assumes that you're already a little bit familiar with TikZ. If you're not, go ahead and watch the previous videos. We'll go ahead and create our document over at overleaf.com. We'll click New Project, Blank Project. Then we'll go ahead and enter the project name of just math in PGF, and we'll create that. Then we go ahead and get organized by closing this left panel and increasing the size of the PDF to 150%. And now I'll go ahead and paste in our own packages here. So we'll use TikZ, of course, because that's what we're talking about. Today we're going to use the TikZ math library, which is essential for doing any math calculations. The packages AMS Math, Parskip, and Full Page are just to make things look nice. And then hyperref is so that when I compile this, it links back to the YouTube channel and the author name. We don't need to use PGF Math inside of a TikZ picture environment, so I actually won't do that for most of our video. But we do need to include this library, use TikZ library math, for everything to work. Now there's one key command that we need to know, that is pgfmathsetmacro. So let me show you a segment of code here. pgfmathsetmacro takes two arguments. One is the name of the macro. So I'm going to call mine /value. And the second argument is what you want evaluated. So I'm going to do something very simple here, just 1 + 1. When I compile that, you can see the result. We can use my value anywhere. Here I'm just using it in my sentence, and the result is 2.0. There are a lot of math functions you can use, as you'll notice as you look at the bottom of your screen where they're scrolling across. Observe that the result that you get here is a decimal value, even though both inputs were integers. If you want an integer result, you have to use int. So let me give you an example here. Here it's exactly the same as before, except for I've added int and parentheses around my prior result. So if I say, what is the value of int 1 + 1, then I get 2, an integer value, as I might have expected. Returning a decimal happens even for commands that you really don't think should return a decimal. For example, if I do round 10/3, you would think that would just return 3, but it returns instead 3.0, as we see here. Adding an int, of course, fixes this, so let me just quickly show you. Here we have the int surrounding our prior result, and everything is fine. And I want to stress that this happens even for commands where you would definitely not expect it, like mod and div. So here I'm using the mod command, and we get mod 5.2 produces a result 1.0, whereas int 5 mod 2 yields 1. So you need to use that int command to prevent seeing a decimal in your result. Now, another thing to be aware of is that you need to use parentheses for grouping. So for example, if I want to do an exponent, so 2 to the -1, I have to put it in parentheses. Mainly I note this because for the LaTeX part, you have to do 2 to the -1 in curly braces. So this uses what I would consider more standard math notation using parentheses. And so just be aware to use those to do grouping for something like a negative exponent. I want to caution you on doing calculations with the TikZ math library. They're okay, but there are some accuracy problems. Let me show you a little segment of code. I'm going to compute 10 to the -1. We just computed 2 to the -1, and the result was 0.5, as you would expect. So 10 to the -1 should obviously be 0.1. So let's see what happens when we compile this. What we get is actually not what we would hope. It's 0.09999. So that's close, but not equal to the correct answer. It's not just a problem of exponents, unfortunately. Even if you just do 1 divided by 10, you get the same wrong answer. So you might run into this frustration from time to time, and so I'm just warning you that it's a known bug, and you just have to be careful when you do these sort of calculations. The PGF Math library has some simple random number generator capabilities. The function rand will return a uniform random number between -1 and 1. So here I just call rand, it doesn't need any arguments, and it returns a random value. Now I've set the seed here using PGF Math set seed, which you can do if you want to get the same random number every time you compile. And then if you change this, of course, you'll get a different random number. So if I change that to 4, now we get a different random number. If I change it to 88, we get a different random number, and so on. Let me just show you a fun little picture using random values. Here I'm going to create a picture, and I'm just going to draw a little set of axes in gray, and then I'm going to draw a bunch of line segments, each one having a random y value except for the first. So if we compile that, we get 0, 0 going to a random y value at 1, a random y value at 2, and all the way on down. So that's kind of fun. That's a simple picture. I'll have a more fun example next week when we do loops. Finally, I'm going to end with some macros for calculating the size of a unit of text. So let me paste a little bit of code here and scroll up. So I'm going to create some PGF Math macros. So I'll have a little piece of text that says goodbye. And so I'm going to calculate its width, its height, and its depth. Now I want to note that you have to say what size the font is going to be. So this is going to be in font size huge. And if I want to be able to calculate its width, I have to put protect in front of the huge so that it is done before it calculates the width. So I'm calculating the width, the height, and the depth, and I'm saving those in macros that are GW, GH, and GD. Now I'll draw a little picture with goodbye inside a node. I've set the intercept of that node to 0, so there's no extra space around it. And I draw the outside in gray, and I'm also drawing the baseline in gray, and you'll see why in a second. Now let me show you what the width measures here. So I'll paste a little red arrow that goes from the southwest bottom corner, and I go down a millimeter, and then I go to the right a length of /DW PT, and that's important to note. The width is calculated in units of PT, so if you don't have the units here, it won't give you the right length. And so now when I draw this little line, you can see it is in fact exactly the width of the text goodbye, and it lines up exactly with the 0 intercept of that figure. Now if I do the height, I'll draw the height line, and we'll see that that goes from the baseline to the top of the text. Notice it doesn't get the bottom here. If we want the bottom, we have to use the depth. So I'll draw the bottom of the baseline down to the bottom of the text by just using that GD PT command. And now I see that that's how I've measured the depth. If you want to get the full height of the text, you need to add the depth and the height. So the height is from the baseline to the top, and the depth is from the baseline to the bottom. I hope you enjoyed today's video. You should know how to do math in your TikZ now. This has many uses, as we'll see in some of our future episodes on loops and other things. There's a link to the overleaf document we created today in the show notes. Please click like or subscribe if you want to see more videos like this. You can also buy my book, Unlocking LaTeX Graphics, at your favorite book retailer. Thanks for watching.